Hi guys, so now we have this question here. It says that 7 friends, 4 boys and 3 girls, want to stand in a straight line next to each other to take a photo. So we have 10.3.1 says that in how many ways can the 3 girls stand next to each other in the photo? Now, so we have these 7 friends here, which there are 4 boys and there are 3 girls. It says that in how many ways can the 3 girls stand next to each other, right? So remember, we have how many friends? We have 7 friends, right? So we have one. So let's say we have 1, 2, 3, 4, 5, 6, 7, right? So what should happen here? The girls must stand next to each other. So we must have a situation like this. This is just one example of the arrangements. Guys, we must have girl 1 here, then we must have girl number 2 here, and then we can have girl number 3 here, right? So meaning that these girls should be arranged in this way. Remember, we can have girl number 3 here, we can have girl number 3 here, or girl number 2, we can have girl number 3, you can have girl number 1, right? So I'm just trying to make a point that these girls here can be arranged in any other order as long as they are next to each other. And then what do we know about that? It is that it means that these girls on their own, they can be arranged in 3 factorial ways. So what I want to do here is to treat this thing as a group, right? So now, meaning that we are only left with how many boys? On the other side, we know that this space here can be filled by boys. So it can be filled by boys in how many ways? We know that it can be filled by boys in 4 factorial ways, right? So we know that boy number 1 can be here, or boy number 2. So in this case, we have 4 choices, and then in this instance, we have 3, 2, 1. Right, so meaning that the boys themselves, they can be arranged in how many ways? In 4 factorial ways, right? But then here is the thing, just because I want to treat these girls as a group, so, or as an item, how many items am I going to have if I just want to treat this as an item? I know that in total I'm going to have 1, 2, 3, 4, 5, meaning that I have 5 items in total, right? So meaning that in how many ways I can arrange those 5 items in total? I said that I can arrange this in 5 factorial ways. But then remember, in how many ways can I arrange the girls in total? I can arrange the girls in 3 factorial ways. And then this is how I can get the total arrangement of this particular question here. So how can I deal with this? So now I can just simply put this into a calculator and then I get the answer here. So now when I put this into a calculator, I'll say that I have 5 factorial. This is going to be multiplied by 3 factorial. 3 factorial. And then I'm going to get that this is equals to 720. So meaning that this type of arrangement can happen in 720 ways, right? So I just write here that this can happen in 720 ways. So this can happen in 720 ways, right? So remember, this was 10.3.1. right? So this is what happens. We want to treat the girls as one item or as one group. So if we want to treat these girls as one item, it means that we are going to have how many items in total? We are going to have 5 items in total. So now we know that we can arrange those total items in 5 factorial ways. But then remember, what is happening in that other group or in that item of girls is that they can be arranged in 3 factorial ways. Then we know that this can be arranged in n ways, and then this can be arranged in m ways. So meaning that to get the total, we have to multiply, right? so that we get 720 weights. So now when we move on to the next question here, we have 10.3.2. It says that now in the next photo, determine the probability that Selwyn and a boy and Lindy were a girl will not stand next to each other, right? So whenever, guys, you come across these instances like this, will not, right? We know that it is not easy, guys, to calculate what not, right? But then it is easy to calculate that the event should happen. Now, what I'm saying is that it is easy to calculate the probability that Selwyn and Lindy were they stand next to each other, right? So how can I deal with this? Is that I know that I have 7 spaces. I have 1, 2, 3, 4, 5, 6, 7, right? What I'm saying is that I want to calculate that S and L, they stand next to each other, right? Because I know that the event that they don't stand next to each other and the event that they stand next to each other, so meaning that the event that they stand next to each other and the event that they don't stand next to each other, they are complementary events, which means that their probability should add up to 1, right? So meaning that if I can find the probability that they stand next to each other and then subtract it from 1, meaning that I'm going to get the probability that they don't stand next to each other. So this is what I'm going to do now. So now I'm going to find the probability that the two, they stand next to each other. So how do I go about this? So remember, I want to treat this S and L as a group, right? I want to treat this as a group. Then I know that it's either Lindy can be the first one or Selwyn can be the first one, right? So I know that these themselves, they can be arranged in 2 factorial ways. Now, remember how many friends now am I left with? I'm only left with 5. So it's 5 here, and then this is going to be 4, this is going to be 3, this is going to be 2, this is going to be 1, right? But then remember, I want to treat these 2 as an item, right? So meaning that how many items am I going to have? I'm going to have 1, 2, 3, 4, 5, 6. So this is 6 items in total. So meaning that these 6 items in total, they can be arranged in 6 factorial ways. And then remember, in how many ways can S and L stand next to each other? They can stand in 2 factorial ways, right? So now we know that in how many ways can these 2 stand next to each other. Then what can we do? We find the probability that they stand next to each other first. So now let's find the probability. So how do we find the probability? You're going to say that this is 6 factorial multiplied by 2 factorial divided by what? Divided by the what? The sample space. And then what's going to be our sample space? Remember, how many friends do we have in total? We have 7 friends, meaning that each sample space now is going to be 7 factorial. So this is going to be 7 factorial. So this is what we have here. So remember that this is the probability that they stand next to each other. So we're doing so, we are going to find that this probability is equals to this, right? So now let me just write the answer. So now we know that this is the probability that the 2, they stand next to each other. Then what can I do to find the probability that they don't stand next to each other? I'm going to subtract this from 1. So what I'm looking for here is that the probability that they don't stand next. So this is going to be next to each other, right? So how am I going to find this probability? While I only know the probability that they stand next to each other, I'm going to say that this is 1 minus the probability that they stand next to each other. Why do I do this? Remember that these two events are complementary events. So how do I go about this? I just put this into your calculator. You can just put this into your calculator, and then you find that the answer is, in this case, so what I'm going to do here, I'm just going to say 1 minus, so 1 minus, this is 6 factorial, so 6 factorial multiplied by 2 factorial. So this is 2 factorial, and then you're going to divide this by 7 factorial. So this is 7 factorial. And then what I'm going to get here is that this is 5 over 7. So this is the probability. Now, this is the probability that they don't stand next to each other. So I got 5 over 7. So now the probability that they don't stand next to each other is 5 over 7.